Hey there, in this video we're going to look at single-threaded and synchronous nature of JavaScript's execution. If you look at it, these are two big words. One is single-threaded, second one is synchronous. Firstly, let's look at single-threaded nature. When JavaScript engine starts executing our code, it's nothing but a list of commands for it to execute. These list of commands, it can execute only one at a time. This is nothing but single-threaded nature. And moving on to the synchronous nature, these list of commands, it will be executing in sequential order one after the other. This is nothing but synchronous nature. Combining these two, JavaScript engine can execute only one command at a time and in the sequential order. Now let's look at this in code. Here I'm going to create a new folder named single threaded and synchronicity. Rename it correctly, synchronicity. Within which I'm going to create an index.js file. I'm going to create three functions here, naming first, second and third, creating one by one. This is our first function. I'm just having a log statement here. First function. In the same way, I'm creating two more, second and third. I'm going to invoke all these three functions one by one, first, second and third. To execute this, I'm giving relative path within our HTML file. Yes, and I'm gonna hit it with live server. This took me to the browser. Yes, if you see, this is the code that we have written. And firstly, we are executing first, invoking first function, which is logging first and then second and then third. In fact, to look at this in a clear way, I can keep breakpoints here. I have gone to the sources tab. I'm opening our file, single threaded and synchronous, this within this folder index.js file, and I'm gonna put breakpoints all over the code wherever the execution happens. Now I'm reloading the page. Yeah, the breakpoint paused the execution here. Firstly, we are invoking first function. So this invocation happens and resuming the execution, and the control went into the definition of first function. Now, once this line of code is executed, first function will be logged here. And then same with the second and third functions. Once second function is executed, second is logged and third is executed and then it's logged. If you see closely, this is nothing but the synchronous nature. Whatever we have written code, it's going to execute it in a synchronous sequential way. I have removed all the breakpoints, and now we are going to tweak this code in a way that let us call second function from first function and then third function from second function. I'm going to reorder the functions in just to make it more readable. Yes. What do you think would happen now? As you might be expecting it, right? Firstly, first function will get logged. This will be logged second and this might get logged third. But let's look at what is internally happening. Let's try to understand that. Firstly, I'm going to take a screenshot of this and bringing that onto the canvas. Yes. And as soon as JavaScript engine starts executing this piece of code, it creates something known as global execution context. It's nothing but any other execution context, but this global execution context will be accessible throughout our code. And there's another element known as execution stack. This is also known as call stack. Now let's look at what happens internally. If you look at this, line number 1 to 14 are nothing but just function definitions. And we don't have any execution lines here. So the execution starts from line number 15, where we are invoking the function first. Whenever we are invoking a function, a new execution context will be created and that will be pushed onto the execution stack. Let's see that in detail. So let's create an execution context for first, and that is now pushed onto the stack. Stack is nothing but a LIFO data structure, last in first out data structure. Now we have our first execution context on the top of stack. Now it starts executing that. Now the control moves on to the line number 11, where it comes across this log. I'm gonna create a block for console as well. This is our console, and let's log this one, first function. And once this line is logged, it moves on to line number 12, where we are invoking second function. As I mentioned, whenever we invoke a function, a new execution context will be created and that execution context will be pushed onto the execution stack. So a new execution context for second will be created and that is pushed on the top of first execution context. Now the control moves into the definition of second function, where we'll be logging second function. Once this log is printed, now here we are invoking third function again. As we are invoking, a new execution context will be created for third and that will be pushed onto the stack. This is our third execution stack. Now the control moves on to the definition of third function, and third function log will be printed. Do we have any more statements left in the third function? No. Now as all the statements within the definition of third function is executed, now it pops off this execution context from the stack. Let me create a duplicate of this, and we are removing third from the stack now. At this moment, we have two execution contexts, one is first and second within our execution stack. And now what is on the top of stack? Now it resumes its execution from the second function. Here log is printed and this is where we are invoking. Invoking is also done. We don't have any other statements left here. So now even the second function execution context will also be popped off from the execution context. I'm gonna drag it a bit here because we have one more step left. Now second function definition is completely executed, and now the control moved on to first function again to the line number 12. Second function invocation is done now. We don't have any other statements left, so this first function's execution context will also be popped off from the stack. At this moment, we don't have anything else to be executed, and this is how internally call stack works. Whenever we are invoking a function, an execution context will be created and pushed onto the execution stack. That is one. And second point is, whatever execution context is on the top of execution stack, that is the currently running code. Let's look that in action now using our sources file. I'm gonna refresh this. Yeah, I'm gonna open our file, JavaScript file. This is our updated code. Now I'm gonna add breakpoints here everywhere possible just to make you understand the flow of execution. Now we are going to focus in this area where we are having call stack. Now I'm gonna reload the page and the execution starts from line number 15. Yes, breakpoint hit here and I'm gonna resume this. Now the control moved on to first function definition. If you see here, now first function execution context is pushed into the call stack, is pushed on the top of call stack. Now first function will get logged as I resume. Let's go to console. See, first function got logged, and now we are invoking second function. As I invoked, the second function execution context is pushed onto the call stack. Now what is on the top of call stack? Second function, that is our currently executing function. This is in turn calling third function. Now third is on the top of call stack. This is logging our value. So far we have two logs in our console, and as I resume, the third function log will also get printed in the console. And as we don't have any other statements left, it removed all the execution context from the stack, and now our call stack looked empty. I hope you have understood how call stack works so far. This is how our synchronous code works in JavaScript. But there could be instances like we are making an API call, or we are waiting for some timeout. These kind of instances are asynchronous in nature. So how do we deal with them? Let's look at that with a very simple example. I'm gonna use set timeout. This intakes two arguments. One is callback, and the second one is the number of milliseconds that we want to wait. I want to wait for 2 seconds. So I have given 2000 milliseconds. What does set timeout do? Internally, it has a timer with 2000 milliseconds, and once the timer expires, it executes this function. That's all what it internally does. I'm gonna have a log statement here. Set timeout, and let me log it before and after as well. Set timeout before and set timeout after. Now let's look at how it's executed by adding breakpoints. I'm going to reload this, and we have our refreshed code here, and we don't have any logs so far. And as I resume the execution at line number 15, all the 3 logs will be printed. We have seen how the flow of execution happens till here. And now let's look at line number 17. After this line, this is the line that we have. Okay, now as I resume, this log will get printed. Set timeout before is printed. And now instead of moving on to line number 19, it jumped to line number 21. Why did this happen? Because set timeout by nature, it is asynchronous. So firstly it logs this value and then moves on to this. In the meantime, the timer starts ticking. Now as I resume, this log will get printed, set timeout after will get logged, and by this time 2 seconds has already timed out. So that's the reason it entered into callback immediately, and as I resume, set timeout will also get logged. Now we had a look at asynchronous execution. This is a very simple example. We have a lot of techniques to handle asynchronous execution, which we'll be seeing in the later videos in the series. Whatever we have discussed so far in this video, what did we learn so far in this video? We have learned that single-threaded and synchronous nature of execution, and then we had a look at how call stack works, and we had a brief into what is set timeout and how it works. All that we have discussed in this video, I have pushed that to GitHub with a very detailed notes along with examples. You can have a look at it. I'm going to provide this repository link in the description box. See you in the next video.